Okay, let us copy this figure first and then we will discuss the problem. So this says a uniform rod AB of mass capital M and length 2L. So this is a uniform rod. AB is a uniform rod of mass capital M and the length of rod is 2L. This is the center of mass of this rod that is in the middle. So this side you have length L, this side you have length L. Rest in a vertical plane perpendicular to a smooth vertical wall. The end A is in contact with the wall. So this side you have a vertical ball and this rod is in the contact with the vertical ball that is given to you. B rest on a horizontal ground. Now point B, that is the other end of the rod, rest on a horizontal ground. This is just smooth horizontal ground and this is also smooth. So you see in all cases, so for all surface in this problem mu is equals to 0. Now question says initially AB is at angle of 30 degree to the wall. So initially this makes an angle of 30 degree. When the rod is released from the rest, so now rod is released from rest, that is important. So initially U is 0 for rod. So it is released from rest. So rod is released from the rest. Question says find the inclination of rod to the ball when A is about to leave the ball. So we have to find theta with vertical. So find theta when point A, that is A, leaves the ball. So when A will leave the ball, that is important point, that if I ask what is the condition when A leaves the ball, so I see what are the forces if I draw the free body diagram. So there are two normal reaction is acting at point B. There is a normal reaction, let us call this as a N1 or you can call it NB. So normal reaction acting at B. There is a normal reaction acting at A. So let us call this as a NA. So this is the normal reaction. Now let us find, so what is the condition when A leaves the ball? So when A leaves the ball, this normal reaction will be 0. So NA will be 0 because this leaves contact. So there is no normal reaction that will act. So when A leaves the ball, the required condition will be, I have to put NA is equals to 0. That's the required condition when A leaves the ball. Now let us find the center of mass coordinate. So let us say center of mass is xy. So I can find coordinate of center of mass at any time. So let us say a rod starts falling. After some time this rod will be here. So let us draw this. So this is initial position of the rod. This is initial position. After some time, let us say this rod has fallen to a distance this. So this is the distance. So it's slightly difficult. I can make the next diagram. So let us leave this one. So let us consider this diagram. So you have, this is the rod situation after falling. Initially let us say it was something like different. So now this is xy, the new coordinate. So how I'll find the next coordinate? So now the angle is theta. Now this length is L and this length is also L. So what is this length? So I want to find this length and this length. So this length is L, so this length will be L cos theta, this length will be L sin theta. So this length is nothing but L sin theta. And once again this angle is theta and this length is L, so this length is L cos theta. So I can put it here. So this is L cos theta. L cos theta. Are you getting? So what is the coordinate of center of mass? So I can write center of mass is L sin theta, that is the x coordinate, and y coordinate is L cos theta. So this is the coordinate of center of mass. Are you getting? So if I write x is equals to L sin theta and y is equals to L cos theta, I can find acceleration in x direction, that is x dot. So this will be L cos theta. and d theta by dt, let us say that is omega. So d theta by dt is omega. Are you getting? Similarly for by, so you will have, so this is Vx, x dot is nothing but Vx. You can write by dot, that will give you V by, that is by dot, that is L cos theta is minus sin theta, and d theta by dt is omega. I can find acceleration in the x direction if I differentiate once again. So I will have A, so let us say L cos theta, let us differentiate omega. So this is Ax, d omega by dt, let us call that d omega by dt is alpha. And then I have to differentiate cos theta, so cos theta is minus L sin theta, and d theta by dt, that is omega square. So this is Ax. Similarly, one can find A by. So if you start finding A by, what you will have, so this is minus L sin theta, and differentiation of omega, that is alpha, and then minus L sin theta is cos theta, and d theta by dt is omega, so this is omega square. So you have Ax, you have A by, you have Vx, you have Vy, you have x coordinate, you have y coordinate. So let us copy this one fast. So if you see, if I write equation in the horizontal direction, so in the horizontal direction, what are the forces that is acting on this system? Only one force, that is normal reaction NA. So you can write in the horizontal direction, force is equals to mass into acceleration. So NA is equals to mass into acceleration, and acceleration is L cos theta into alpha minus L sin theta into omega square. Now you see, we have already said when this just leaves the contact, Na is 0. So if I plug this is equals to 0, I will have L cos theta into alpha minus L sin theta omega square, that is equals to 0. So from here I can get a condition. So let us cancel L. So I will have cos theta into alpha, this is equals to L goes out, omega square sin theta. So let us skip this equation, we will use in the latter. So let us call this equation 1. Now what we want is, now this system is a smooth, everywhere there is no friction, so I can also use energy conservation. So let us see here. If I try to use energy conservation, this normal reaction NV is acting perpendicular, but this point is moving in this direction. So the movement and normal reaction are perpendicular to each other. So this normal reaction does not do any work. Similarly, this point is moving in this direction, normal reaction is acting in this direction. So even this normal reaction does not do any work. So this system, you can say the friction force is not there. Normal reaction always does not do any work because normal reaction is always perpendicular to the motion direction. So I can say Na and Nb does not do any work. Na and Nb does not do any work. Does not do work. So this means I can apply energy conservation. So if you apply energy conservation, that is the loss in potential energy is equals to gain in kinetic energy. Gain in kinetic energy. So if I write, so what is the loss in potential energy? So you see, initial situation of the rod is something like this. Center of mass is here. That angle is 30 degree. Now this angle is theta. So you can find what is this height of center of mass. So this angle is 30 degree. This length is L. So initially this was a height of L sin 30. So initial potential energy is mgl sin 30. Are you getting? Now the potential energy you have, that is this angle is theta. So mgl sin theta. mgl sin theta. So what is the loss? So loss is mgl sin 30 degree minus sin theta. That is the loss. Now what is the gain? So kinetic energy, what are the kinetic energy you have? So if you see this rod has a velocity in the x direction, velocity in the y direction. So if you see here, so let us make a diagram. So basically this rod now has its velocity in x direction bx, it has a velocity in y direction by, and this rod is also rotating with angular velocity omega. So you can say the total energy of this rod will be, I think you have copied this one. So total energy will be half mvx square plus half mvy square plus rotation. Due to the rotation you will have energy, that is half I omega square. So if I put this value, so total energy will be half mvx square plus half mvy square plus half I omega square, and for this I will be, so moment of inertia for rod over the center of mass is generally given as ml square by 12. This is the moment of inertia, but the length is here 2l, so I will be m into 4l square by 12. So this is simply I is equals to ml square by 3. So the moment of inertia for this rod is ml square by 3. Are you getting? So I can plug this value ml square by 3 here. So I is equals to ml square by 3 into omega. Are you getting? Now if I cancel m throughout and take 2 this side, so I will have 2zl, and sin 30 is 1 by 2 minus sin theta. This is equals to vx square plus vy square plus, so half I omega square will be there, so this is not omega, so l square omega square by 3. So this is my expression, the final expression we have from that is coming from energy conservation. Now basically we can put the value of Vx and Vy from this equation. So you see your copy, Vx is given by L omega cos theta and Vy is given by as L omega sin theta. So if I plug this value, so this side will be same, 2zl 1 by 2 minus sin theta, and this side will have Vx is L omega cos theta, so this will be L square omega square cos square theta plus L square theta, that will be 1. Are you getting? So let me explain once again. So this is L omega cos theta square, this is square, so this will be 1. So we will have L square omega square, and this is also, so 1 plus 1 by 3. I am going slightly fast, but you can understand. So this is 4 by 3. So 4 by 3 L square omega square, and this is equals to 2zl 1 by 2 minus sin theta. Are you getting? Now if you plug these values, so let us differentiate this equation. If I differentiate this equation, so we will have 2zl, and 1 by 2 differentiation is 0, sin theta is cos theta, and d theta by dt is omega, is equals to 4 by 3 L square omega square is 2 omega, and d omega by dt is alpha. So if you plug these values, so you will have 2zl cos theta, omega goes out with a minus sign, so you will have 4 by 3 L square into 2 into alpha. So this 2 goes, L also goes, so you will have minus g cos theta is equals to 4 by 3 L into alpha. Now you plug the value of alpha in the previous equation, so you have this equation. So let us say equation for normal react for alpha. So this equation, if you plug the value of alpha from this equation, basically I have done a mistake. You see, this height is not L sin 30, this is a cos 30. So this height is cos 30. Now here also, this will be not sin theta, this will be cos theta. So that is a mistake. Now here also we will have sin 30, in place of sin 30 we will have cos 30. Here also we will have cos theta. I think you are able to understand. So if you do this one, sin 30 is root 3 by 2, and difference is, so this is cos 30, cos theta. Are you getting? So here also we will have root 3 by 2, and this is cos theta, so this is not sin theta, so this is cos theta. Are you getting? Same here. root 3, and this sine theta is basically cos theta. Are you getting? I can write this once again. So if you differentiate this equation, so there is a mistake, and that is the problem. If I will in the class, you can point out this mistake, but if I am doing my own, it's difficult to pointing the mistake. So I can understand if you are doing a mistake in the exam, it is very difficult to catch up the mistake. So if you differentiate cos theta, that will be minus sine theta, so minus minus plus, so this will be simply sine theta. Are you getting? Now everything will remain same, only thing I will have, so this is minus minus plus, and this will be sine theta, and this will be sine theta, and there is a plus, so this is the sine theta. So I will have g sine theta is equals to 4 by 3 L into alpha. So this is the equation. Now you see the first equation for alpha we have, so let us say copy one equation, let us call this equation 2. What is equation number 1? You see equation number 1 here you have alpha cos theta is equals to omega square sine theta. So equation number 1 you have alpha cos theta is equals to omega square sine theta. What is my target? My target is to find out theta. So what are the unknown we have? Omega square, alpha and theta, 3 unknown. I need one more equation. So one more equation I have from here. So you see this equation, I know the omega square basically in terms of theta. That is this equation 2zl. I can write into root 3 by 2 minus cos theta. So let me write minus cos theta. This is equals to 4 by 3 L square omega square. Are you getting or not? So what is the omega square you have? So 2 to go, so you will have z, and L also goes, so g into root 3 minus 2 cos theta, and this is 3 comes this side, 4 goes this side, by L, so this is omega square. So 3z by 4L into root 3 minus 2 cos theta is basically omega square. Are you getting? So let us call this is equation number 3. So now we have 3 equations, and what are known? We have omega as unknown, we have alpha unknown, and we have theta unknown. So using these 3 equations we can solve for omega, we can solve for alpha, we can solve for theta. So this question asks what is theta. So how to solve theta? So let us say equate these two. If I plug the value of alpha in this equation, so g sine theta is equals to 4 by 3L into alpha, and alpha is nothing but omega square sine theta by cos theta. So omega square sine theta by cos theta. Now what is the value of omega square? This is the value of omega square. So plug the value of omega square here. So sine theta goes. Are you getting? So you will have 3z. So this side, this cos theta comes this side. Cos theta is equals to 4L, and omega square is 3z by 4L. So this is 3z by 4L into root 3 minus 2 cos theta. So root 3 minus 2 cos theta. Are you getting? Now only thing is to solving this equation. So let us try to solve. So what we have, so this equation 4L goes out, so you will have z also goes out, so you will have 3 cos theta is equals to 3 under root 3 minus 2 cos theta. So you see 3 also goes, so you will have 3 cos theta is equals to root 3, so you will have 2 cos, so 3 cos theta is equals to root 3, so cos theta is basically 1 by root 3. Are you getting? So this is the angle when this rod will leave. Are you getting? So when this rod makes an angle theta, where theta is given by cos inverse 1 by 3, in that case it will leave the contact. Now if you want, I can basically find what is the value of cos inverse 1 by 3. So 1 by root 3, 1 divided by root 3, and I need cos inverse for this value. So cos inverse is where? So this is the cos inverse of answer. This comes out to be 54.73 degree. So this is 54.7 degree. So let us say this is around 54.7 degree. So you see what is happening. Initially rod was here. So initially this is the situation of rod. After some time rod is basically inclined more. So you will have, of course this rod is not getting curved. This is again a straight. Now this angle keeps increasing. So initial angle is 30 degree. This angle keeps increasing, and when this angle becomes 54.7 degree, at this point of time rod loses the contact here. Are you getting? Now let us discuss this problem. What is the important point we have in this problem is to write down the equation of motion in this question is very important. For that what we have done is we have written x coordinate and y coordinate of center of mass. This is the first step. So let us write the x coordinate and y coordinate of center of mass and then differentiate these coordinates. If you differentiate this coordinate, you will get Vx, you will get Vy. Further differentiation will give you acceleration Ax, acceleration Ay in terms of omega. Omega is basically d theta by dt. This says what is the rate by which this theta keeps changing. So this theta is same as this theta. So rotation about center of mass will give, so d theta by dt will give you what is the angle by vertical is rotating. So this center of mass, rotation about center of mass. So omega is basically giving you rotation about center of mass. This angle and this angle is same. So this will give you omega, Ax and Ay in terms of omega. This is the first part of the question. That is the first you have to set up a coordinate, and once you have set the coordinate, you have to differentiate the corresponding equation to get Bx, By, Ax, Ay. That is the first task in terms of omega, of course. Because the rod is doing three kind of motion. It is going in the x direction, it is also falling in the y direction, it is also rotating. So I have to have three components, that is Ax, Ay and alpha, Vx, Vy and omega. Now, so we are getting Ay and X in terms of alpha also. That is also important. So you see what are the unknown we have. So many unknown, Bx, By, Ax, Ay, omega and alpha. 6 unknown I have in this case. So you have Ax, Ay, Vx, Vy, alpha and omega. These are the known we have. You see, now question gives me condition. So question gives, we have to find theta when normal reaction is 0, that when just leaves the contact, in that case acceleration Ax will be 0, because in that case there is no force is acting. Basically you can write equation normal reaction is equals to mass into acceleration. So Na is equals to max. Na is 0, so from that condition you will have Ax is 0, because normal reaction in the horizontal direction is 0. Now you can write another equation, but we are not writing another equation in the vertical direction, and I am not writing torque is equals to I alpha. I am not writing force is equals to mass into acceleration in y direction. So these two equation I am not writing. For this I can, for alpha one can write torque is equals to I alpha equation. For y direction one can write F is equals to ma/y. But we are not writing this equation. If you want, you can write this equation and try to solve. That will also give you the same answer. But what we are doing is, indirectly I am writing these two equations. We are using the energy conservation, because this system writing energy conservation is very easy. There is a loss in potential energy, gain in kinetic energy. So if I write energy conservation, I will get an equation, and if I differentiate that equation, that is very basically equivalent to this equation. So this equation is energy conservation, and if I differentiate that equation, that gives me condition in terms of alpha. So, and later if we solve this equation, so let me see. So if you differentiate that equation, you will get in terms of alpha. And now you have three equations and three unknown you can solve always. Are you getting? So what are the important points we have? You have to write x and y coordinate of center of mass first. Second important point, differentiate these equations, get the corresponding velocity and acceleration. Third important point we have, that is at the time of when the normal this leaves the point A leaves the contact, normal reaction will be 0. From that, acceleration in the x direction is 0. Now the next important point, system is a smooth, no friction, energy is conserved. So from there, what we are getting equation of energy conservation, and that gives me a relationship between Vx, Vy and omega. And if I differentiate that equation, that also gives me a relationship between Ax, Ay and alpha. Of course, in this case Ax is 0. So even if I am using this equation and I am eliminating Vx and Vy initially also, so you see what we are doing before differentiating, we are eliminating Ax, Vx and Vy. So what we are doing here, so you see before differentiating, I am not interested in Ax and Ay, I am interested in omega. So that's why I am putting the value of Vx, Vy and I am getting omega. Are you getting? This is a good trick. Before differentiating this equation, I am putting the value of Vx and Vy, that is Vx is L omega sin theta and Vy you see L omega cos theta, whatever, you can check your copy. So this is all about this problem. We'll discuss the next problem.